So in your notes, we have an example that looks something like this. Again, not drawn to scale. I'm going to label the corners A, B, C. We've got a side length of little c being 12, of little b being 10, and of little a being 8. And again, it says solve the triangle, which means we need our grocery list of things to find. So we need to find angle A. We need to find angle B. And lastly, we need to find angle C. All right, now before we even get some values for these sides, we can make some predictions about their relative values, because we know that the littlest side, or the shortest side, should have the smallest angle. The medium length side should have a medium-sized angle opposite it, and the largest side should have the largest angle opposite it. So when we do get our final values, we can kind of do a little self-check to make sure that our values are reasonable. All right, I'm given side, side, side. Let's start maybe by finding angle A first. And so again, what I want you to do is make sure you tell me what it is you're doing so that your solution is clear. Otherwise it becomes a lot of calculations and it's hard for me to sift and sort what you're doing. So because we're starting with angle A, we can say that cosine A is equal to, and we can subtract little a squared over here. And I'm going to do the general formula first and then we'll sub in some values, which means that little b and little c will go here, and little b and little c will go here. Let's go ahead and try it. So the cosine of angle A is equal to, well, little b is opposite angle B, so it's 10. Little c is opposite angle C, so it's 12. And little a is opposite angle A, so it is 8. We divide all of that by 2 times B, which is 10, and C, which is 12. Now again, we can do all of this in our calculator in one step, or if you're uncomfortable with that, you're not sure if you'll get the order of operations right, you can simplify the numerator and simplify the denominator separately and then do the division. Okay, that's entirely up to you. How about I'll do them separately in this round, but then I'll also show you how to do it all at once. So here's how I would do it separately. And I'm going to use the one that shows what you're punching in as you go, this type of calculator. So let's do 10 squared plus 12 squared minus 8 squared equals, and I would get 180. So I could put 180 on top here. And 2 times 10 times 12, well, 20 times 12 would be 240. Okay, you can put it in your calculator if you don't believe me, that's okay. And it makes sense that we'll end up with a ratio that is less than 1, because when we learned about the cosine ratio for angles that are smaller in nature, and we can expect that this is almost an equilateral triangle, so they're all going to be less than 90. That it should be a value between 0 and 1. So if I do 180 divided by 240, I get 3/4 or 0.75. Now I don't have to put approximately equal to 7.5 because it is exactly that. Okay. Before I go ahead and solve further, I just want to go back and show you how you could do all of this in one step if you wanted to. So you're going to have to use brackets so that your simplification of the numerator and the simplification of the denominator are done first with the division in between. So I could do bracket 10 squared plus 12 squared minus 8 squared. I'm going to close that bracket. There's the numerator piece. Divided by, and then I'll do the denominator piece in brackets too. 2 times 10, I'm not going to punch that separately, I'm just going to go 20 times 12, or like I did in my head down here, you could just put divided by 240, equals, and there you go, I got 0.75 the same way. Okay, so you don't have to do this intermediary step if you want to, but you got to be super careful that you punch it in correctly. Going forward, to solve for A, the only thing that's getting in the way is this cosine function, and we've learned in previous lessons that using inverse cosine is what will negate or cancel out the cosine function. And of course, whatever you do to one side of the equation, you have to also do to the other side. So angle A is equal to the inverse sine. I've already got that number in my calculator. Let's leave it there. And let's do the inverse cosine of my previous answer. And I get an angle that is approximately equal to 41 degrees. And again, it doesn't say in the example how many decimal places to use, so our standard will be round to the nearest degree for angles and to the nearest tenth for side lengths. All right, now, for those of you who have the different type of calculator where you can't see what you're punching in, let me show you what that would look like. Okay. If you want to do it separately, top and bottom, I think it's pretty straightforward. The key punching in would be actually identical to the other type of calculator. But if you want to do it all at once, you would have to use brackets as follows. So bracket 10 squared, I'm going to punch in 100, plus 12 squared is 144. Save myself a bit of time, do some mental math in here. Minus 8 squared, which is 64. I'm going to close the bracket. There's that 180. Okay, that I had here, divided by, and then I got to do brackets again for the bottom, and I told you I mental mathed it before to say 240. Close your bracket, equals 0.75. You get the exact same answer. If you want to go to this step, the nice thing about this type of calculator is you don't have to hit answer. This has already got the answer function in there. We can just go to, and I've already engaged the second function button, the inverse cosine of it. Bam, 41 degrees. So there's a little bit, sometimes fewer buttons you have to push with this type of calculator, but not always, okay? But I want you to be able to use both types. All right, so we got one thing off the grocery list. Let's now go to the next piece, and maybe I'll write it in here too, just as I go, so that I can do that final check it in of do my answers make sense. So for angle B, I could do all this all over again, okay? But why would I? I notice that it's a lot of steps. It's a lot of thinking and a lot of places that go wrong if I try to skip steps. So what I can recognize now at this point in the problem is that I have an angle and its opposite side pairing. Well, that's a condition for sine law, and sine law is a little bit shorter than cosine law. So it's not uncommon when you're using cosine law to solve for a triangle that you end up using sine law with it. So let's find angle B. So angle B, right here, I'm going to put again in the top left because it just makes rearranging the equation easier. I'm going to ratio it with its opposite side length, so sine B over 10, and then I can set it equal to one of the other pairings that I have, in fact the only pairing I have, which is sine 41 all over 8. Now while I'm doing all this, I just want to pause for a second. I'm going to keep that 41 in my calculator with all its digits. Don't clear it just yet, because even on paper, if we're showing some rounding and applying sig-dig rules, let's let our calculator keep the best answer it possibly can. So just keep it off to the side for a second. All right, let's rearrange this. So in order to solve for B, I first have to multiply both sides by 10 to negate dividing by 10. And so I can just put a 10 in front of sine 41 because that implies that 10 is being multiplied by sine 41. So at this point I'm left with sine B is equal to all of this. If I want to do the least amount of writing possible but still communicate my thinking, at this point I could take the inverse sine of both sides. Like this. And then I would be left with angle B. Now, again, I have that angle in my calculator right away. How would I take the sine of it right away and multiply it by 10? So I could do the sine of my answer times 10. It doesn't matter what order when I'm multiplying, which one goes first, which one goes second. That distributive property, or that reversal property is pretty cool here. And then I can also divide by 8. So there's my value that's inside the brackets. I can now take the inverse sine of it by engaging the inverse sine button of that answer that I've just had in my calculator. And lo and behold, I get about 55.8 8. We're going to round that up though to 56 degrees, and we'll put approximately, because again, that's not an exact answer. It's been rounded, and we communicate that with that approximately equal sign. All right, we've got 2 down, 1 to go. Well, once you know 2 angles in a triangle, finding the third one is a piece of cake, because we can use a very simple property that is true for all triangles, regardless of what size angles they have. We know that the third angle has to be equal to 180 minus the other 2 angles. I'm going to pause for a second here and put my angle B up because I got a little carried away and forgot to do that. 56 is here. So 180 minus 56 minus 41. All right, let's check it out. $83 degrees. I'm still going to put a approximately equal to because it was also based on using some rounded angle values as well. All right. Does this all make sense? Well, at the very beginning of the lesson, we said that the smallest side should be opposite the smallest angle, and the medium angle should be opposite the medium-sized side. There it is. And the largest side should be opposite the largest angle. And they are. So that gives me a numeracy sense that my answers are in the right ballpark. If I didn't have that relationship at the end, I'd know I'd made a mistake somewhere. All right, there's cosine law for you. Okay, using it in a SAS situation if you're given side angle side, or using I like to call it, or side side side, where you're given all 3 sides. You need to find the angles in the middle. Have fun with your practice, and as always, send me an email or communicate with me if you have any questions or you need any help. We're going to do one final consolidative lesson for this unit. I'll post it as soon as I have it up. Thanks.